spend so much of our lives trying to get things right, to follow the plan. But what if the most important signals, the patterns that really shape our world, are hidden not in our successes, but in our mistakes? Today, we're decoding a pattern that began with exactly that, a simple, fortunate accident.
It's a strange question, isn't it? I mean, we're all taught to avoid mistakes, to stick to the plan. But today, we're going to dive into a story where the plan completely failed. And right there, in that failure, a signal emerged that would quietly go on to remake the entire modern world.
Yeah, and what's really wild is just how often this happens. Some experts estimate that somewhere between 30 and 50% of all scientific discoveries are, in one way or another, accidental. They weren't the goal of the experiment at all, but something else that just popped up.
So let's get into our story. It starts with this really dedicated bacteriologist who was on a mission to find a wonder drug, one single thing that could cure all sorts of diseases. He knew exactly what he was looking for.
And this really gets to the heart of what we're talking about, this idea of serendipity. It's so much more than just dumb luck. It's about finding something incredibly valuable when you weren't even looking for it. It takes what the scientist Louis Pasteur famously called a prepared mind, that ability to actually recognize when an accident is something more.
Our story is centered on a man named Sir Alexander Fleming. Now, he was a brilliant researcher, no doubt about it, but he was also, he was famously messy in his lab. And as it turns out, this small character flaw would end up being the absolute key to this entire discovery. Okay, so picture this. It's London, 1928, at St. Mary's Hospital. Fleming walks into his lab after being away for 2 weeks on holiday. He starts sorting through this pile of old Petri dishes he just left stacked on a bench. Totally normal, mundane stuff that could have easily gone unnoticed. As he's cleaning up, he picks up this one particular dish. It was growing Staphylococcus, a pretty nasty bacteria. But because he'd forgotten to cover it, a random mold spore had just floated in through an open window and started growing on it. Now, for any self-respecting scientist, this is a ruined experiment. It's contaminated. You're supposed to just toss it and start over.
Right. And that is the crucial moment. Most researchers, probably 99 out of 100, would have just thrown it in the bin without a second thought. But this is where the pattern starts to emerge from all the noise. Instead of just seeing a mistake, Fleming saw something else entirely. He saw a signal.
So he leans in and takes a closer look. And he realizes it's not just a random mess of bacteria and mold coexisting. There's an interaction happening. Something was going on in that dish that just wasn't supposed to. If you look closely, you can see what he saw. There was this clear zone, a perfect little halo right around the blob of mold. The bacteria grew everywhere else, but it couldn't get near the mold. It was like there was an invisible force field. The mold was clearly putting out some kind of substance that was killing the bacteria. That was the signal. This is what they mean by our prepared mind. It doesn't just dismiss the anomaly, it gets curious about it. Fleming himself put it perfectly. He totally acknowledged the role that pure chance played in his work. He was looking for his wonder drug, but he never, ever expected to find a clue in a contaminated, forgotten dish. It shows you how serendipity works. Sometimes the discovery finds you, not the other way around. So Fleming isolates the mold, figures out it's from the Penicillium family. He spends a while after that trying to extract this mysterious bacteria-killing stuff, which he gave the very glamorous name mold juice. But the signal was pretty weak, The substance was incredibly unstable and just really, really hard to work with. And this is where the mystery takes another strange turn. You'd think, okay, this is huge, right? But it wasn't. Fleming had stumbled upon one of the most important signals in the history of medicine, but for more than a decade, that signal just went completely silent. It's like the world wasn't ready to hear it yet. So why was it ignored? Well, a few things were going on. He did publish his findings, but the scientific community pretty much shrugged. Fleming himself wasn't a great salesman for his own ideas, and critically, he just couldn't isolate enough of his mold juice to prove how powerful it could be. So the whole thing was dismissed as this interesting little lab curiosity, but not a revolution.
So for over 10 years, this life-saving pattern just lay there, totally dormant, hidden away in some obscure scientific journal. It became a cold case. The initial clue was there, but nobody knew how to decode it or what it really meant.
And then, a full decade later, the case was reopened. A totally new team of researchers down at Oxford University, a team with the resources and, more importantly, the chemical expertise that Fleming just didn't have. They picked up the trail.
Two researchers, Howard Florey and Ernst Chain, stumbled across Fleming's old paper and got fascinated by it. And by now, with World War II just beginning, the need for something, anything, to treat infected wounds on the battlefield was more desperate than ever. They decided they were going to try and finish what Fleming had started.
And this is how they finally cracked the code. They brought a different skill set to the problem. They were biochemists. First, they managed to isolate the active ingredient. Then they figured out how to purify it. Then stabilize it so it could actually be used as a drug. And then came the final crucial step. They developed a way to mass produce it, turning a laboratory curiosity into a medicine that could save millions of lives.
So what was the result of finally decoding that one accidental observation in a forgotten petri dish? Well, it was nothing short of a complete transformation of human life as we know it.
It's honestly hard for us to even imagine what the world was like before penicillin. A simple scratch from a rose thorn in the garden could get infected and actually kill you. In wars, more soldiers died from infected wounds than were killed in combat. Penicillin changed absolutely everything. For the very first time in history, we had a real weapon against deadly bacteria.
The numbers are just staggering. Thanks to penicillin and all the antibiotics that came after it, the death rate from infectious diseases today is just 5% of what it was at the start of the 20th century. Hundreds of millions of lives have been saved, all from one messy, contaminated petri dish.
And so, in 1945, the Nobel Prize went to all three of them. It was a fitting tribute to the team that collectively solved the puzzle, the man who first spotted the signal, and the two who finally decoded it.
It just makes you wonder, though, doesn't it? The answer to one of humanity's biggest problems was just sitting there, hiding in plain sight for a decade. How many other world-changing signals are out there right now, just being dismissed as errors or contamination or noise, just waiting for a prepared mind to notice them?
And that's really the key takeaway here. Progress isn't always this neat, straight line that we imagine it to be. Sometimes the biggest breakthroughs aren't on the map at all. They're lurking in the detours, the anomalies, the mistakes. The story of that moldy dish is just one pattern, and it leaves you wondering, what other patterns are we all missing right now?